Okay, so we continue with question 1b. So question 1b, this is question 1. Question 1b. Okay, so question 1b, the question reads, find the sum to infinity of the series 3, 1, 1 over 3. It goes. Okay, so find the sum to infinity of the series, this one, geometric progression, the GP, this one, geometric progression. So how do you how do you solve sums under geometric progression? The infinity. So sum to infinity, this is the symbol for infinity. This is the symbol for infinity. Sum to infinity is equals to, you have your a here over 1 minus r. This is the formula that we are going to use to solve each and every calculation that we'll be dealing with infinity, the sum to infinity under geometric progression. So this is the formula that we are going to use. This is the infinity symbol. This is the first term. This is the common ratio. And here we can, this is the first term being given. We can press it here. This, the common ratio now, it is the one which we are supposed to calculate. How can you find the common ratio if you've been given this sequence like the way it is here? Remember that the way we do come up with the common ratio is to divide starting from this point going this. So it will be 1 over 3 divided by 1. That's 1 over 3. What is 1 divided by 3? That's 1 over 3. Remember, that's how we calculate the common, that's how we get the common ratio. If we have been given the sequencing, like we have this, we have these numbers. So we divide starting from this point going this. But when it comes to arithmetic progression, we subtract this to come up with the difference in between. But when it comes to GP, it's going the other way. Arithmetic progression is going this one. We are not dividing in arithmetic progression, we subtract. But when it comes to GP, geometric progression, we do what? We divide. So it will be 1 over 3, we divided by 1. That's 1 over 3. So that's our common ratio. Even if you get what is 1 divided by 3, it will still give you 1 over 3. Okay, so we continue. So this is the formula that we are going to use. So what next? The sum to infinity is equals to, what is our first term? The first term being given, it is 3 here, over 1 minus, what is the r, the common ratio? What is 1 over 3 divided by 1? That's 1 over 3. So it will be 1 over 3 here. Okay, so when you reach this stage, what next? This one, 1 over, what is 1 minus 1 over 3? I'll do the simple math so that you understand the steps. So this one, since it is a fraction, and this one is the whole number, so it will be over 1. What is the common denominator here? It is 3. 1 into 3, that's 3. 3 by 1, that's 3. Minus 3 into 3, it's 1. 1 times 1, 1. So what is 3 minus 1? That's 2 over 3. So this is what we're having down. So the sum to infinity is equals to 3 over 2 over 3. This is the main division that we're having. So we can rewrite this as, you have the sum to infinity is equals to 3, we divide it by what? 2 over 3. When we reach this stage, what next? Since there is a division here, we reciprocate. This goes up, this comes down. That's how we reciprocate. So if this one goes up, this one comes down, meaning we're going to change the sign, which is, we're going to put cross multiplication. So the sum to infinity is equals to 3, we multiply by, so this one goes up, this one goes up the 3, so it will be 3 over the 2 comes down 2. That's, we have reciprocated. So since we have this, 3 by 3, 9. And when you reciprocate, there's a cross multiplication here. Not start doing, what is 2 times 3? Who told you that that's how we multiply? There is a sign here, cross multiplication. It's 3 by 3, this by this, numerator by numerator, denominator by denominator, not numerator by denominator, denominator by numerator. There's no such kind of multiplication when it comes to mathematics. We don't multiply like that. Once you include a multiplication table, once the sign has been included, like there's a multiplication table, there's no any other sign here apart from the multiplication table. Multiply direct. 3, the numerator by numerator, denominator by denominator. And remember that this 3 here is the whole number, so it has a denominator of 1 down. So 3 by 3, that's 9. So meaning the sum to infinity is equals to 3 by 3, that's 9, over what? 1 times 2, that's 2. So 2 into 9, it goes how many times? 4. Remainder, 1 over 2. So this one becomes your final answer. Simple. You get the marks that you're supposed to be given. And in this case, they were just giving out the 4 marks. You have your 4 marks. Nothing else. We proceed to question C2. So question C2, we have to deal with the logs. Okay, so here, I'll solve the logs here. This is question 1. This is question 1C1. Okay. Question 1C, Roman numeral 1. So the question says, solve the equation. We're supposed now to solve the equation. We've been given this log. You have log, open bracket, x raised to power 3 minus, x raised to power 2. X raised to power 2 minus 3 minus log x equals to log 2. Okay, this is the first question that we've been asked actually to solve. Solve the equation. So you have this one. You have log, open bracket, x squared minus 3 close minus log x is equals to log 2. Remember the rules under the logs, what we are supposed to be doing. There's nothing like, no, I'm supposed to do this, and the rules are they're just direct. When it comes to dealing with the logs, like the way it is here, there is a negative, meaning it's supposed to be a division. That's the rules. If there was a positive here, it was supposed to be what? To be multiplication. If there's a negative, you divide. There's a positive, you do what? You multiply. Simple rules. So it's just a matter of following up what the rules says. Then everything under the logs, they'll be to be simple, like simple for you solving. There'll be nothing like, no, what am I supposed to do, and the likes. Okay, so like what I've said, here if there's a negative, what are you supposed to do? You divide. You divide the bases given. If you have if there was a positive, what were you supposed to do? You multiply the bases given. You multiply, I mean these bases given. So here, the logs that we are having, we have log x raised to power 2 minus 3 in brackets, and log x is equals to log 10. Okay, so when you identify this, okay, I'll say they were using the log of base 10, because here it's not indicated. So this is what we are having. So you're supposed to know the rules to say, if there is a negative, what am I supposed to do? I'm dealing with the logs. No, if there's a negative, I'm supposed to do what? I'm supposed to divide. If there's a positive, what am I supposed to do if I'm dealing with the logs? Oh, no, if there is a positive, I'm supposed to multiply. Okay, so since we know that if there's a negative, we are supposed to do what? We're supposed to divide. Keep the log. We have our log here, open bracket, so it will be x squared minus 3. Remember, we keep the log, then we divide the bases given. So we have, since it is x raised to power 2 minus 3, then we have this one, log. So we have x, we have this, equals to log 2. Simple. I'll take you back to the rules of indices. Okay. The rules of indices says that you have something like this. The rules of indices says that if you are dividing, what are you supposed to do to the powers? You subtract. If you are dividing, the bases are the same, what are you supposed to do to the powers? You subtract. But when it comes to the rules of logs, if you are subtracting the logs, what are you supposed to do? You divide. If you're adding the logs, what are you supposed to do? You multiply. So the rules of indices, for example, I have 2. The bases are the same. I have 2 raised to power 3 divided by 2 raised to power 4. I have something like this. The rules of the indices says that if the bases are the same, then you are dividing. What are you supposed to do to the powers? You subtract. So what do? We keep the base, which is 2. Then I do what? I subtract the powers. What is 3 minus 4? That's negative 1. So meaning our final answer to be 1 over what? 1 over 2. These are the rules for indices. If the bases are the same, 2 raised to power 3, then I'm multiplying 2 raised to the power 4. If the bases are the same, then you are multiplying. What are you supposed to do to the powers? You add them. So what do? We keep the base, we add the powers. What is 3 plus 4? That's 7. Then on the calculator, it's 2 raised to the power 7. You get your answer here. These are the rules. Now, when it comes to the logs, it's vice versa. If the bases are the same, you have log x plus 5 minus log 2x minus 2. If the bases are the same, meaning this one is supposed to be that's log base 10. I'll take it that way because here the bases are not indicated. What do? Since there's this subtraction here, what do? We divide. What do? We divide. Remember, here under division, what do we do to the powers? We subtract. But here, since there's a subtraction here, what do? We divide. So you keep your log, open bracket, you divide. What is x plus 5 over 2x minus 2? This is what we mean. Same applies to if there's a positive here. Log x plus 5 minus log 2x minus 2. Sorry, plus 2x minus 2. What plus 2x minus 2? What are we supposed to do? If you are multiplying, the bases are the same, then you are multiplying. What do you do to the powers? You add them. There's addition here. What are you supposed to do? You multiply. So you keep your log here, open bracket, x plus 5, 2x minus 2. This is multiplication. You multiply. So this is what I'm trying to mean on the other side. Okay. We can proceed. But if you find the log which is being indicated, like you have log maybe 2, then you have x here. Yeah, you have something like this. Then minus log 2x minus 2 is equals to log 2. You have something like this. You cannot divide these two. Why? It's because the bases are different. Here the base, it has been indicated as in base 2. But here the base it is not indicated. So if the base is not indicated, just know that it is 10 which they have been talking about. Here the base, it is not indicated. It is just log 2x minus 2 is equals to log 2. So meaning these two, they are the same. Why? It's because their bases are not indicated. So we just count them as in their base 10. Log in base 10. So you can get these two equate to this. So you can move this here. So you can have something like you have your log 2 here, because this one, it doesn't have a friend. So you have to take this, the log 2x minus 2 to the other side, which is to log 2. So it will be this one equals to, so you're going to have your log 2 minus, it is negative when it comes this side, it will be positive, plus log 2x minus 2. You can solve something like this. So you keep your log here, log 2x equals to, then this one, there's a positive now here. The bases are the same. There's a positive. What do? You multiply. Simple. So this is what I was trying to say here. So you keep your log here, then you multiply 2, now these two. So it will be 2, you multiply by what? 2x minus 2. Try by all means to come up with something like this. This is what I was trying to explain on the logs. Now at least I've covered the indices part and the log part. So at least now you have an idea of what I'm trying to of what I'm trying to say. So we continue now here. So we have this. So we have this. What are we supposed to do next? Okay, we have the log and the log. They are the same. What do? Let's just cancel them. There you go. So that at least we remain with these figures. We start now dealing with the figures being left into our equation. Okay, so the logs and log are out now. So you have your x squared minus 3 over x, which is equals to 2. You have something like this, becomes an equation. So what are you supposed to do? It will be over 1. You cross multiply. Now here, there was an equal sign here. I've just included the what? The cross multiplication. So you cannot do direct whites because there was another sign here. This the sign which was here, it was just being indicated like this. There was this sign. There was nothing like, no, you have to reciprocate or what. No. There was a sign here which is an equal sign. I've just had to put a cross multiplication. So you cannot do direct like this. No. You have to go this way. Numerator by denominator now. Denominator by numerator. That's how you're supposed to multiply. But if you had to reciprocate and change the sign completely, because here there was a sign which is an equal sign, it's there, it's showing. Hope I'm clear. So we continue. So what is 1 by x squared minus 2? You're going to have x squared minus 3. 1 times x squared minus 3. You're going to have x squared minus 3. There's an equal sign here. Now I'm saying that the sign didn't change. Equals to, so what is x by 2? What is x by 2? That's 2x. You have something like this. What comes in your mind? What comes in your mind? Factorization using the difference of two squares, factorization using product and sums. You can factorize it using graphical methods if you want. Yeah. So when you reach this stage, you're supposed to know the stage to say, okay, if I reach this stage, this is what I'm supposed to do. So for me, what is always simple, like when it comes to factorization, I do use the product and sums because to me it becomes simple. Okay, so I have x squared minus 3 is equals to 2x. I just correct them in the way of a x squared plus bx plus c equals to 0. I have this one. Or if you want, you can do what? You can use the almighty formula, which is x equals to negative b positive or minus the square root of b squared minus 4ac over 2a. You can use that one if you want the almighty formula. Even the almighty formula, it becomes simple for me if I have like in this situation. Okay, so for the sake of trying by all means to explain at least each and every stage, we are going to be going by that way. Okay, so we have this. So I have to arrange this equation in this form here. Ax squared plus bx plus c equals to 0. So that if you want, you can use the almighty formula x equals to negative b positive or minus the square root of b squared minus 4ac over 2a. You can use that one, but I'm going to use the product and sum root. Okay, so what we're going to have here is you're going to have your x squared, it maintains. This one is negative, it is 2x. When it comes this side to be negative 2x, I keep my negative 3 here, which is constant, equals to 0. So I have something like this. So you can use the almighty formula. Okay, let's use two methods so that we come up with one answer. So the almighty formula, this one is our a, b, our c. So it will be x equals to negative b positive or minus the square root of b squared minus 4ac over 2a. Okay, here it will be direct. You know what we are supposed to do and you know what's next. So it will be direct. There will be nothing like, no guys, what are we supposed to do and where is that 2 coming from? That negative, where is that negative coming from? You have to know when it reaches this stage. So we have x is equals to, this is negative b and b is negative. So negative becomes positive. So it will be just our 2 here, positive or minus the square root. What is our b? Our b is negative 2. So it will be negative 2 in brackets squared minus 4. What is our a? Our a, we've been given a here. We are only getting the coefficients of that variable being given. We're not getting together with the variable, no. We are getting the coefficient of that variable being given. X here, the coefficient of x squared, it is 1. The coefficient of x here, it is negative 2. And 3 here, it is the constant. Yeah, so what is the coefficient of x squared here? It is 1. What is our constant? It is negative 3 over 2. What is our a? It is 1. So you have something like this. So here we have x equals to, we have 2 positive or minus. Okay, so this stage, I just do punch everything on the calculator. So it will be, what is our negative 2 here? So it will be open bracket, negative 2 you close, squared, minus 4, open bracket, 1 you close, open bracket, negative 3 you close. You have 16. The square root of 16, we have 4. So it will be 4 over 2 by 1, that's 2. So it will be x. Sorry. So it will be x equals to, what is 2? We are going to start with a positive, then later on a negative. What is 2 plus 4? That's 6. 2 into 6, that's 3. 2 into 6, that's 3. Or, what is 2 minus 4? That's negative 2. 2 into negative 2, that's negative 1. So we have these answers here. Remember, the question says solve the equation. So you are supposed to come up with how many answers? With 2 answers. When it comes to this part here, because we have a square, meaning the answers you're supposed to produce, they're supposed to be 2. Okay, so our answer, we have 3 or negative 1. Let's go, we use the root of product and sums. Okay, So the root of product and sums we have to calculate as well. Remember that the way we are solving past papers, that's the way we're going to be learning topic by topic. Okay, so it was x squared minus 2x minus 3 is equals to 0. Okay, this one here, x squared minus 2x minus 3 equals to 0. So let's solve this using the product and sums, so that those who doesn't know how to solve using product and sums, please rectify your mistakes here. So first step that we do normally, it's just multiply. You multiply the first variable together with the coefficient, the constant. So it will be this one times the constant. What is if you want, you can multiply the coefficients, or if you want, you can get everything. Okay, I'll just be getting everything. What is x squared times negative 3? That's negative 3x squared. Okay, then you get, when you multiply, that's a product. Remember, for you to come up with a product, meaning you have to multiply. You cannot come up with a product if you didn't multiply. Then this one here, which is on the middle, becomes the sum. So the sum of negative 2x. So the one which gave me negative 3x squared, it was a product. I had to multiply x squared times 3 times negative 3, which is negative 3x squared. But for the sum, I had to get the one on the middle. So meaning for the sum, if I have to come up with the sum, I have to add two values, two values or two numbers. But if I have to come up with a product, meaning I have to multiply two numbers as well. Again, those same two numbers, what are the numbers whereby when I multiply them, I'm going to have negative 3x squared, and when I add them again, I'm going to have negative 2x. What are those numbers? So when you get your negative 2x here, when you get your negative, not 2x, sorry, but when you get your negative 3x here, you put your negative 3x here, and you get your x, negative 3x here, and you get your x, or your 1. So when you multiply, it is negative 3x times x becomes negative 3x squared. But when you add, what is negative 3x plus x becomes negative 2x. That's how it is. Negative 3 plus 1, that's negative 2. So meaning these two becomes our answer. So these two are the ones we're going to substitute here on the sum. So we keep this x squared, then we get this. So it will be plus x, because this one is positive 1x. We cannot write positive 1x as well here. Just write the x. Okay. Minus 3x minus 3. I've just this positive x, which is this one, minus 3x, which is this one. This has to go out. Equals to 0. Then this. You do this. Then you factorize. Here, which one is common? X. Open bracket. X into x squared, that's x. Plus x into x, that's 1. You close. Minus. Which one is common here? 3. 3 into 3x, that's x. Negative into negative, positive. 3 into 3, 1. You close. Equals to 0. These two, they are the same, meaning we are correct. So you get this one and this. Then you just choose one here. So it will be x minus 3. You close. Open bracket, x plus 3. Oh, sorry, x plus 1. This, it's x plus 1, x plus 1, x plus 1. You close, equals to 0. So meaning x minus 3 is equals to 0, or x plus 1 equals to 0. So you collect like terms. X equals to negative, when it comes this side, it will be positive. So it will be, what is 3? So it will be positive 3 plus 0, that's 3. You have this. Or x equals to, this is positive 1. When it comes this side, it will be negative 1. So these are the answers that we found in the previous method we used, the omit formula. We had 3 and negative 1. Which are these answers here? 3 and negative 1. Okay. So we proceed to the next question. We proceed to question 2. Okay. We proceed to question 2. Question C2. Question C2. So question C2, we've been asked to do what? To solve the equation as well. So we have our 2x plus 1 equals to 3 2x minus 5. Okay, 2x minus 5. So what are we supposed to do? What is supposed to be the first thing we are supposed to put into considerations, since we've been given these two equations? So what you are supposed to do, you have to think. You can pause the video, try by all means to solve the question if you're going to make it, and try by all means to compare with our answers. Yeah, so yeah, you can pause the video and try by all means to do what? To solve the questions. So if you've been given such kind of a question, or if you come across with a question which looks like this, here you don't have you don't have the same bases. If the bases were the same here, if you had the 3 here, it would be it would have been simple for us. Why? It's because you just have to cancel the 3 and the 3 here, then you remain with x plus 1 equals to 2x minus 5. Then you collect like terms, you solve, you find the value of x. But in this case, it's different. We have 2 on the right side, on our left hand side, and the 3 on our right hand side. So what are we supposed to do? We cannot cancel this and this. Here, the brains remain stuck. So what we can do, we can introduce the rules of logs, or the rules of ln in. Yeah, so you can use that one. So I'll use the rules of logs. So once you introduce the rules of logs, so this one, since it is x plus 1 as the power, we drop the power and introduce the log. So it will be x plus 1 log 2. Okay, is equals to, even this one we drop the power, so it will be 2x minus 5 log 3. This is how we do it. So if you want to take back the powers with the logs, so meaning this one becomes here, this one becomes here, then you can cancel the logs. It will go back to this, like what I did when I was trying by all means to show you. If you're dealing with the negatives and positives, you're dealing with the logs and the indices. What I mean is, you have something like you have x plus 1 equals to log 2. This one you can take back the power. This one, it goes back, becomes the power of this. It goes back, becomes the power of this. So it will be 2. It will be log 2 raised to power x plus 1. Same applies to this one, which is equals to, again, when you take back this one to be log 3 raised to power 2x minus 5. Then since the logs are the same, what do? Cancel them. You remain with 2x raised to power x plus 1, 3 raised to power 2x minus 5. It goes back to your question. Okay, hope now it's clear. We are going step by step. So when you reach this stage, what next? I have this. I can divide throughout with the logs. Okay, what are we supposed to do? A log 2 is a number. Log 3 is a number. We can divide them. Let's divide both throughout by log 2. Also here by log 2. So that we cancel log 2 and log 2 goes. We remain with x plus 1, which is equals to, we remain with x plus 1 equals to this one now here. What is log 3 divided by log 2? Here the log, it is in base 10. Even this one is in base 10. Why? It's because the logs here are not indicated. Like what I said, to say if the logs are not indicated or not, you've not been told actually like this is log 2 or log 3. If it's just a log with a number the way it is here, meaning this log, it is in base 10. So this one is log 3, log 2. All the calculators, they were being programmed. Like if you just see a log, that's when you just see a log, meaning that log, it is in base 10. That's how all the calculators were being programmed. So it will be our log 3, you divide it by log what? By log 2. You get these values, 1.58, 1.585. I'll get this, 1.585. So it will be 2x minus 5 open bracket 1.585. I have something like this. What next? I proceed. I can solve now the equation. So I have x plus 1 equals to this one. This one is, it is the multiplier of everything. What is 1.585 by 2x? I'm going to have 3.17. So here to be 3.17x minus, what is 5? 5 by 1.585. I have 7.925. 7.925. Okay, yeah, we can solve now. We collect like terms. So it will be x, this one goes this side, it will be x minus 3.17x equals to negative 7.925. This one is positive. When it comes this side, it will be minus 1. Something like this. We proceed. What is here? This x, it has a coefficient of 1. So it will be 1 minus 3.17. What is 1 minus 3.17? We're going to have negative 2.17. Negative 2.17x equals to, what is negative 7.925 minus 1? Negative, negative, you add, you get the sign of the bigger number. So it will be negative 8.925. You divide throughout by what? Negative 2.17. Even here, negative 2.17. You cancel. Meaning your x equals to, what is negative 8.925. You divide it by negative 2.17. You get 4.11. Yeah, 3. It becomes your final answer. Meaning you have calculated for x. Meaning you have solved for what? For x. Simple. We proceed to question now 2. Okay, we have calculated for x. We will proceed to question 2.